Very good afternoon, everyone. Now, today we would like to have a coverage of your topic exercise, right? You will see that. And in the past 2 weeks, so we just covered those 3 chapters on textbook 4A, the rate of reaction. Okay, so shall we have a big recap of what we have learned so far? First of all, we start from we start from some formula to come up with the volume of gas. Okay, volume of gas, and trying to relate to the number of moles of gas, and the volume of gas. Right, we have got the relationship between the two. Right, so you know that. So what is the relationship between the two? So this is the first one. And second, you are going to get to know some measurement method of reaction rate. Okay, so we have depending on the different types of reaction, we have got different method to measure the reaction rate, and there is some rationale behind. And three, what you have is to get to know the factors affecting the reaction rate. Okay, the factors affecting the reaction rate. So we have got some of the factors together with some explanation in molecular viewpoint. Okay, so molecular viewpoint. So in short, what we just talked about is collision. Okay, just collision theory. So this is what you may know about those three. So all those they just covered textbook 4A. While for the MCs in your public exam in paper 1, here comes 2 MCs, and for the long questions, here comes 1 long questions about 5 to 6 marks. Okay, well, for 2 MCs, you know, here comes 2 marks. So altogether, you may find that it ranges about, it will give you about 8 marks. 8 marks in your paper 1 out of 120. So nearly one level up, right? And because of that, you should know that for this part, okay, for this paper 1, and rate of reaction, it lays a very good foundation for you to get to know more about the industrial chemistry, one of our electives. Okay, one of them very, very popular electives, as that you may know it, in Form 5, summer, or maybe in Form 6, and you will get to know this. Okay, so this is what I would like to tell you how important it is. Okay, after this lesson, we will have a quiz. Just remind all of you. Okay, at least for those attendant for those people who are just here, you should get to know that we have got a quiz. Okay, don't just hide away. You have to attempt the quiz on energetics after our lesson. Can you get the point? You should get to know that we have got a quiz after at 2:50. So topic exercise, take a look on that. Would you mind, could you please help turn off the mic? Now, so shall we take a look on 99, page 99. So we start from MC first. Now take a look on that. Is it something about rate of reaction? Rate of reaction, question A. We have got the different rate curve. So which one will best represent the results of experiment? Take a look on that. So we have got 0.03 mole of Mg, and the axis to be used is 20.0 cm cube 1.0 molar. So which one should be the correct answer? So to start with, you know the equation, right? The equation is Mg plus 2HCl to form NgCl2 together with hydrogen gas. Now, So it's just a comparison of A and C, right? While you see that B and D, the graph is rather strange, right? Because for the before the reaction, before the end of the reaction, if you see the straight line, which means that we'll have a constant rate of reaction, right? So of course, B and D doesn't make sense. How about A and C, right? One of you choose the answer is C. How about the others? Is it A or C? And give me the reason. C. Someone say C. Any reason? Wang Zhenhou, tell me the reason. Why is it C, not A? So yes, you are going to calculate which one is a limiting agent, right? So Mg is 0.03 mole of Mg. So H2HCl, what is that? 0. What? 0.020 mole. So according to the equation, we have got 1 to 2 mole ratio. So what is the hidden message? If you are going to react to 0.020 mole of exit, you only need what? You only need 0.0100 mole of Mg only. Okay, so the remaining, some of the Mg will be remain unreacted. Okay, so you use this to project the number of moles of H hydrogen gas. You may see that Mg project to hydrogen gas is 1 to 1 mole ratio. 1 to 1 mole ratio. And so here comes this one, 0.1. Okay, that's it. This is C part. Questions? Any questions? Anyone who knows what's that? So you have go. Let me know that you know. You understand? Now, how about question 2? Question 2. Shall I invite the people in the class, right, to tell me the questions one by one? Okay. I start from the list, the topmost of the list, and I will do it alternatively. The one on top and the one below, one by one. Hey. Question 2 and 3 refer to the following setup. Now we have got a very authentic Mark-Cross experiment, right? It seems that something will form and which will mask the cross. So something will form, which means there may be something like turbid mixture, right? You will see that turbid mixture. So there will be some PBD that will form. They will mask the cross. So you look it from above, the cross will no longer be seen after some time. So the question comes: we have got different trials, right, with different combinations of molarity of A and molarity of B. So you may find that A and B will have a change, while the H2O, the volume of this is just a complementary one. You need to add it until all those they are the same. So you may find that 40, 40, 40, okay, horizontally. So which one is the answer? So here you just circle quite a lot of things. I still do not comprehend which is which. You circle as C. Could you please tell it one by one? We've got so many circles here. I do not understand what is meant by that. So could you please do it again? Tell me, how would you know that the change in B will affect? Yes, change in B. So wait a minute. Now this one, you will want to take a look on B. Right? If you want to take a look on B, what is that? You are going to this one. You're going to take a look on A and B, right? So only B, the concentration of B changes, right? The concentration of B decrease by half. So what will happen to the time? Okay, they will decrease also by half. Times 2. Sorry, I make it wrong. I'm trying to compare with 1 and 2. So we have got 2, which means that what? Rate times 2. Okay, so you may note rate we have got a inverse proportion to time taken, right? So this is by doing so, you may find that A, the changes in concentration of A would affect the reaction rate. How about concentration of A? If these changes, would it affect the result? The answer is no, right? Is no, does not increase with A concentration. The way to compare is with two data, right? That is A, 1 and 3. So you may see that 1 and 3. So for 1 and 3, can you see that 1 and 3 will have got the only molarity of A changes, while keep B constant. Okay, by adding the volume of water in different ways, so you may find that the time is the same, which means that no effect. So this the answer is C. Questions?
Now, guys, please do make sure you access the site every now and then to check the latest updates.
Sorry, Cyrus, you should be attending economics class, isn't it? Why are you here? Or you cannot just open all the videos and then just pretend you are here. I know that some of you just open it and just let me know that you just exist. You just exist but not listening to the lesson. Multitasking. Okay. Okay. So which means that whenever I ask whoever can answer, right? Simply because you think that you will be quite able to multitask. Question 3. Some of you just circle D. Why? It's 何展鵬, is it? Tell me. What is that? You are going to find out which one can you measure the rate to study the rate. How? Why will you circle that手法？
佢問個題目問嗰個 can rays be studied by the above set up 嘛？上面嗰個圖係講嗰個係顏色咧遮住嗰個交叉嘛，跟住整出嚟嗰個收法咧係有顏色嘛，所以當即係整出嚟收法越多嗰時會遮住嗰個交叉咯，所以係 D 咯。
All right, so how about A? Why not A? Why not A? Why not A? We've got sulfur. We've got calcium sulfate, which is also a solid.
嗰個 calcium sulfate 係咪冇色啊？其實我唔肯定啊呢個。
Solid. If you find something more soluble in water, so you will see it. Will still see it? The answer is yes, right? You still see it. So what is the color of the powder form? What is the color of the powder form of those salt, calcium salt? Is it in form of a white powder? Okay, not colorless. It is in form of white powder, white precipitate. So the question comes, well, we have got A and D, which will have solid. While that solid, we will say that it will mask the cross, right? But why will you choose D but not A? But why not both are correct? Can you get a point? Okay. 張家榮 do you know? Calcium carbonate is fine powder. Calcium carbonate where? I did not mention anything about calcium carbonate. Calcium sulfate. So as sulfur. Sulfur is also it is in form of a fine powder. Why can't we choose A? Now take a look. It seems quite a number of you do not understand. Anyone who know? Anyone who know the answer? Why can't we use? Why can't we choose A? Or why not both A and D are correct? Now the more important thing is to take a look on A and D respectively. The way to form that precipitate. A is what? What is the type of reaction? Right? It is simply a precipitation reaction. So can you tell me the rate of reaction of this? Can you estimate the rate? Do you know? The rate of this precipitation is too high. Do you know? So high that direct mixing and the precipitate have already formed. Okay, but for this part, for the formation of sulfur, the formation of that is gradual. So you need to spend some time on it and wait. So the cloudiness of those solution is gradual. Okay, they will have a gradual change in the cloudiness in the solution. While for this one, upon mixing, they will all in a sudden turn to cloudy. And the reaction has stopped. Do you understand? So this is question 3. It's not just checking the physical state of the product, solid, but also what? But also you need to check the rate of the reaction, such that it is a moderate rate and it will be studied well. But not for A. A, the reaction is too fast, so you cannot measure the rate by using that type of adjusting concentration of the two chemicals respectively. Do you understand? For those who understand what I've just said, could you please put a tick here? Just quite a number of you. Zhang Kunwei, are you here? And Chen Zihin, are you here? And Mr. Boon, are you here? Don't just walk away. Oh, some of you are not here, right? You let me understand? What is that? Where we are in question 3. Golopan, are you here? Tell me if you understand it. Okay, so this is about question 3. About question 4, take a look. A very strange curve, right? So you may have got 2 scenarios. Trial 1 and trial 2. Take a look at that. In the 2 trials in the experiment, a substance is decomposed and the gas dissolved is measured, which the following shows how the rate of reaction varies time in each trial. So we have got a very strange curve like this. So what is that? So A and trial 1 and trial 2. Now, do not get caught. It's rather confusing, right? Because we have got 2 areas to consider, it seems, right? But if you take a look on the A, B, C, D choice, you may find that you just mentioned, you just know something about the rate of reaction, right? The change in rate over time. The change in rate over time. Could you please see that? Okay, you know it. So just split it into half. Take a look on trial 1. Trial 1. For trial 1, the rate of reaction is what? It's lower, right? Can you see that? First of all, it's lower, and then trial 2 is higher. So the trial 2 is higher than trial 1. 2 is higher than 1, okay? So you may see this one. Trial 2 higher than trial 1, okay? So it's not D, it's not A. Can you get a point? Can you see my way to solve the problem? How about next to it is on, we have got a overlapping area here, right? And then finally, trial 1, what happened? Trial 1 would have a later stop. They will stop here. Later stop than trial 2. So can you say that? So remember, trial 1 will stop later than trial 2. So which means trial 2 first, and then trial 1.
佢嚟冇尖嘢。
Okay, so this is what I would like to talk to you. It is the answer is B. Do you know how to get approach to the question? Okay, so why will you say that stop and then you just mark it? You know it, right? When the reaction stop, which means rate becomes rot. It becomes 0, right? So you are going to check the point. Understand? You understand? Now you take a look on question 5. Question 5, Xu Junhei, take a look. The setup below, this one. The setup below is to study the rate of a reaction between calcium carbonate and different acids. Which one shows the highest initial rate? Highest initial rate of the reaction. I asked Xu Junhei to answer. Pencil, you are so poor, right? No one help you. B, tell me reason. Why is it B? So what factors should be considered? What factors should be considered? Powderized. So what is mean by that? It seems that you miss out those lessons, such that you just give me layman terms. A good question for checking whether or not you have watched the video. Pencil, you better watch the video. Now, first of all, is on the solid. That is the difference in the surface area. Surface area. Don't just tell me powderized, no marks. Don't you know that? In the whole week, I just mentioned it many times. Isn't it good? Just admit that you did not watch anything. I asked you the reason. First of all, the surface area of solid. The surface area of solid for the powder is largest, right? When you compare with lumps. Okay, second is about the acid. Now, for the same molarity of acid, this one HCl, it is a strong acid. So what is mean by strong acid? It would affect what? So what items are we going to consider? This one. The concentration of what? Of acid? No, they are the same. But something is different. Concentration of hydrogen ions. Can you get a point? Concentration of hydrogen ions. Yeah, that's right. Can you see that? Concentration of hydrogen ions, we have got to change. So this is the key term. You have to tell me that is the items to be compared. So this is question 5. Question 6. Question 6. H2O2 decomposed, blah, 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 okay? So I find something, some other people to answer this question. Question 6. The decomposition of hydrogen peroxide. are you here? 1, 2, 3, not here. Just tell me. Yes, you just A, reason. If you choose B, tell me reason. Someone say A, someone say B. Tell me the reason first of all. Now you are going to compare the rate of formation of this one at the start, which means you are going to compare the initial rate. Okay? So the initial rate of oxygen gas depend on what? Take a look on the case. Now we have got 50 cm3, 100 cm3, 2 molar, 1 molar. So which item should be considered? It is the concentration of H2O2. Can you see that? This is the item to be considered, but not the volume. Only this. Just compare which one has a higher concentration, and the one would have a greater rate. Okay. So this is correct. This two is correct. Okay. So concentration of H2O2, they would affect the initial rate, right? How? When concentration H2O2 increase, the rate will increase, right? So you may see that 1 is greater than 2. Same volume of O2. Why? Why is the same volume? Now, yes, that's right. You get the point, right? So you are going to consider what? The total volume of H2O2 is related to the number of moles of O2, right? So this one, you are going to find out from what? The number of moles of hydrogen peroxide, right? This one will affect the number of moles of O2, which in turn affects the volume of O2 to be produced. Can you get a point? So you are going to calculate the number of moles of the two, which is what? It is 0.100 mole of hydrogen peroxide for both cases. Can you see that? For both cases, they have the same number of moles of reactant. So of course, they will form the same number of moles of product. So is reflected by the total volume of O2 form the same. So the answer is A. Do you understand? So once again, right, I ask you guys to consider this equation, this type of questions based on 2 items, right? What is that? Do you still remember? Zhang Gawing. Zhang Gawing. I just checked with someone have watched my video. I just want to double check. Zhang Gawing, are you here? Hello, 1. The question is, okay, when considering that type of reaction, right? That type of questions about rate of reaction, where we mainly consider 2 concepts. What are the 2 concepts? Do you understand? Surface area and concentration of reactant. You take a look on the first 6 questions already. It's not just surface area. It's not just this. Now, these two collectively, it is just under one concept only, right? Which is the factors affecting the rate of reaction. Okay? The factors affecting the rate of reaction, they are different. Rate of collision and activation energy. Well, all those they just related to one concept, which is what? Which is the factors affecting the rate of reaction. They are just what you just mentioned is just the factors affecting the rate of reaction. But it's just part of them. How about this one? What concept do we have? You calculate one. You need to know something about mocap. Can you see that? So 2 different main concepts that you need to know. Limiting, Zhang Gaowing, take a look on question 6. We just have one reactant. How come you say it is limiting? Do you know equation? Do you know equation? The equation is we have got H2O2, decompose it to water and oxygen, right? So just this one. How come you say that limiting? I got. Okay, just blame the internet connection then. For not letting you answer the questions correctly. Agree? Suddenly found that the ground is so hard. Now question 7. Question 7. Do you find this? We have got 100 cm cube of 1.0 molar HCl reacts with excess zinc granules, giving curve A in the graph below. Very, very authentic question, I must tell. Very, very authentic. Now, this question also appeared in the year 1, I forgot it's 90 or 91. CE, very similar equation that appeared, that question. Some of you say D. Cedric, tell me the way to get approach to the problem. Have you watched the video? Don't say have you watched a video on rage? So, who else haven't mentioned anything? Mặc Diêu Lam. Mặc Diêu Lam. Tell me the reason, please. Why is it D? Mole of reactant. Can you elaborate more? How does it affect which part will be affected if you say that mole? Now, Zhang Kunwei, good. Higher molarity of HCl leads to the higher initial rate of reaction. So that's right. So first of all, if you take a look on this one, that too, right? You're going to check the exit. The molarity exit is larger. So first of all, this part, you're going to consider this part. Can you see that? So the concentration of exit they would affect the rate, the especially initial rate of reaction. So we have got this part. So B is steeper with a steeper curve than A. Okay, and then what's the next question? So first of all, it's about the second part. Second part, what is that? So you are going to calculate what? How about second part? How come the level of part, right, the A is higher than B? You need to consider what? Mole. Yes, that's right. The mole of what? Of HCl, which affect the moles of hydrogen gas. So you may know that the zinc is in excess. So the exit number of moles is different. Take a look at the first case. The first case is 0.100 mole of exit. How about this? How about this? 50 times 1.50. What is the number of moles? It's 0.0750. You have got only two sig only, right, this time. 0.075 mole. So you may find that, of course, this will lead to a less hydrogen gas to be formed. You got it? All of you have got the answers? Okay. So take a look on question 8 then. So remember, I just like this one. A rate on the first half, mole on the second half. Question 8. Take a look on question 8. The emergency oxygen system in the passenger aircraft using the decomposition of sodium chlorate to produce oxygen. So this one. So temperature and pressure inside the craft. Each adult passengers need 1.60 dm³ of oxygen per minute. And so the question comes, what mass of the sodium chlorate is required to produce the required volume of oxygen for each adult passenger per minute? So it seems the question seems very complicated, right? Per minute, each adult passengers, they will need 1.60 dm³. So this is the parts that you may need to know, which means that the number of moles, how you calculate it? How you calculate it? The number of moles of O2, okay, each passenger needed per minute. So you are going to calculate this, right? So it is just 1.60 dm³, the volume of oxygen, over what? This time the molar volume is very strange. It's 32.2. Can you see that? dm³ per mole. It's not 24. Now this is given. And you are going to change it to form it as 0.0497 mole. Okay, and then what's next? What's next? I use this to take a look on this. Right, we have got 0.0497 mole. Okay, altogether 3 portions, 3 mole, right? And then you are going to project it back here, right? So 2 mole. Yes, that's right. So this is what, so the number of moles of sodium chlorate, it is what? 2/3 times 0.0497 mole. And here comes the 0.0331 mole. And finally, you are going to ask about the mass of sodium chlorate. So it is simply the number of moles times its molar mass. Its molar mass, NaClO3, a very large number, 106.5 gram per mole. So you may get the answer, which is 3.53 gram. Okay, the answer is A. Something about mole. Do you feel fine about this question? Okay, could you please put a thumbs up if you, yeah, 2, 3, or at least somebody who give a very instant response. For those thumbs up, right? No lagging. 11, yeah, 12. Okay. 陳偉豪and 張家榮, your lagging problem is not due to the internet connection. Do you hear me? No? So take a look on question 9. I don't know. So take a look on question 9. What an inconvenient truth you want me to give my understanding about this phenomenon. Now question 9. Question 9. Something about molecule. Aluminium. I don't know why. Now aluminium and carbon. And 0.180 gram of X react with excess water to produce a gas. It is aluminum carbide, right? The chemical name we call it is aluminum carbide. But the question is, you need to get to know the formula of this aluminum carbide. And the gas burns completely in oxygen to form water. And this one as a carbon dioxide, measured at room temperature and pressure. So the question comes, how do we get approach to the problem? And that is our concern. So what is the use of these data and this data? Okay, now first of all, for carbon dioxide. So which means that you are going to have an aluminum carbide with what plus water to form what? An aluminum compound without carbon, and then the gas burn completely the oxygen to form water, and that is the end group of the carbon dioxide. So what is that? A gas, but I still don't know what is the gas, and then O2 to form CO2, right? It seems that there are two equations. Right, the first one we have with water to form a gas, while the gas they will burn completely oxygen to form another gas is CO2. But anyway, you may see that this CO2 where we have that carbon that will help you come back to this carbide, right? So you may know this C, right? All those C come from this carbide. Okay, so this is the underlying principle. So based on the 90 cm cube of carbon dioxide, what will you get? Is the number of moles of carbon. Okay, so you get a point. You use the data of carbon dioxide, the volume of carbon dioxide, to come up with the number of moles of carbon. Number of moles of carbon. So you may find that number of moles of carbon, it is equal to number of moles of what CO2. Also, it is equal to 90.0 times 10 to the power minus 3 dm cube over what? Over 24.0 dm cube per mole. So you get the answer. It is 3.75 times 10 to the power minus 3 mole. Okay? So you use this. And what's next? Do you know what to do next? You use this to project what? So what is X actually? X contains aluminum and carbon. So can you tell me the mass of carbon in the compound X? Can you you may get this, right? So 3.75 times 10 to the power minus 3 times what? Times 12.0. Here comes what? What is the answer? 3.75 times 10 to the power minus 3 times 12. Here comes 0.045 gram. So you use this data and you get to know, right? We have got this one, it is 0.180 gram. Here comes 0.045 grams. So what is that? So you know what is that, right? It is the total. Okay? Can you get a point? So the mass of aluminium in X, it is 0.180 minus 0.045. Okay? So it is 0.135. So you may get to know that you are going to find out the mole ratio between aluminium and carbon to form 0.135 over 27.0 to what? Actually, this is what? 3.75. 3.75. So this is the one. 3.75 times 10 to the power minus 3. That is a mole. Okay, this is the mole ratio. Okay, so what we get? 0.135 times over 27. So here comes 5.00 times, can you get it by 10 to the power minus 3 to 3.75 times 10 to the power minus 3. So this, which is what? 5 over 3.75. It is 1.33. So which is 4 to 3. 4 to 3. The answer is C. Can you get it? You get all those, right? Question 10. It's easy, right? A, correct. Why? Calorimetry. Only during the progress of the reaction, the color intensity of the brown color of iodine increase. Okay? The brown color of the iodine increase. So the answer is A. Okay? Question 11. The progress of some reaction can be followed by using the experimental setup below, which setup is suitable. So you are going to find out the drop in mass, right? Is expected. So it is usually related to the gas form. So you are going to find out which one will have a gas form. The answer is B, correct. Okay, this one CO2. No other gas, right? No other gas form this one. So the answer is B. Take a look on question 12. Question 12. So once again, take a look on the half, right? Before and after, right? You consider mole here and you consider rate here. What changes in the condition results in the curve Y? The question is exit to a metal, right? Exit to a metal, exit to a metal. So Y will have got a faster rate. Faster rate, so concentrated exit is related this. Increase the temperature also related to this. How about 2? How about 2? It is very, very tricky. Can you see that increasing the particle size? What is mean by that? Which means decreasing the surface area of solid. Now, so remember that is a very tricky point here. Very, very tricky. So could you please mark a star here? Don't get confused about this term. Increasing surface area of the metal, which means decreasing particle size. Okay, so this time I increase the particle size of a metal, which means originally it's a smaller pieces. Here comes larger pieces. Okay, larger pieces, of course, surface area is smaller. So the answer is B. The final 3 questions before you end up lecture today. Question 13. Now very tricky. Equal mass. Can you see that? Equal mass of Mg and Ca is added separately into dilute excess exit. Ca will produce a greater volume of gas. So this is what? Is it rate or mole? Greater volume of gas. Is it rate or mole? Is it related to rate or mole? It is related to mole, not rate, okay? So this is a very important item that I would like to address to all of you. So the question, statement 1 is correct. Calcium and magnesium added to is wrong. How wrong is this? If you consider the mole of the gas, is it the same, greater or smaller? If you use calcium. It's not greater, it is. Yes, it is smaller. Second, more reactive, this one I know it is cross and take is C. Yes, that's right. You have going to consider the molar mass of this. This is 40.1 and this one is 24.3. Okay, you calculate equal mass, of course, the number of moles. For calcium, it is smaller, right? Because of this RAM, it is larger. Okay. Question 14. 1 mole of dilute sulfuric acid reacts faster. So remember the term faster. Now, faster. Can you see the word faster? So something you need to relate, right? Same granule, same powder, faster, surface area. Granules is larger than powder. So yes, do you see the tricks? D, what is the tricks? What is mean by granules and powder? Granules, we've got the size of this, while the powder is just this. How about lump? So 3 different size of solar particles while you describe. And you may find it very commonly in your exam, right? Lump, granules, powder. Do you know it? Okay. So 15, the last question. At room conditions, the volume of 1 mole SO2 is larger than 1 mole of N2. The answer is wrong. This one is not larger, it's the same. According to Avogadro's law, they are the same, right? Irrespective of the nature of the gas. The first statement is cross. The number of atoms constituting 1 mole of SO2 is greater than the constituting 1 mole of N2. Now, 1 mole of SO2 we've got 3 moles of atoms, right? 3 moles. How about this? We've got 2 moles. So the answer is greater. Yes, that's right. This is cross and a tick. Here comes C. Okay? You get a point? You do find it difficult, easy, or what? Do you feel more confident after doing this MCs, right? If I were you, please start over doing the sort by topic MCs. Okay? It's not too much actually. Have you checked your MC paper? How many? How many? It's not that too much. It's topic 9. We have got 37 questions. 37 questions plus 36 questions plus 37, 36. That's it. Okay? It's just how many? 73 questions overall. So I'm sure you can deal with it. Okay? I urge all you guys, right, after doing your quiz on energetics, it's time to go back to rage and also energetics MCs and try to have a better practice. Okay? Are you okay for that? Just a few of you mentioned your feeling, right? Just 10, 10, 10. Quite nice, right? 10, 8, 10. Good. How about Zhang Gaowing? Just lag? Just lagging? Lag? The internet setting is lagging or you just left behind? Zhang Gaowing, hi. You didn't say anything. Huh? Ian 咪要鬧。陳龍話要do you feel fine? Okay, so get prepared for the quiz on energetics. Okay, see you guys. Bye-bye.